Good morning, guys. Welcome to another episode of Ksao Talk Show. You are watching Ksao Talk Show, and today is 2019. This is Saturday, December 14th. In USA, of course. Now it's 12:30 in the afternoon, and 12:30 in the afternoon, and San Francisco time. Welcome to San Francisco. You want to go to San Francisco? You take the train. And today I'm going to show you the fantastic writing of Chinese and vectors. Okay, mathematics and geometry, the all important stuff you don't remember in school. Oh, okay. So how are you guys? So let's see. I'm still setting up. I am. Oh, okay. So apparently when the video is going on, this becomes scratchy. You see, I'm trying to draw a circle, but it's not as smooth. Can you see? Can you guys see? So today we are going to talk about vectors. For example, this is x and this is y, and we have a point here, and the coordinate of this point will be a and b. Okay, so scratch that. So undo. What is undo? Oh, I don't have a key for undo. Okay, so I don't have a. So that is a point, for example, and that point will be the coordinate will be AB because this is A and because this is B. So each point in the plane is represented by two numbers, a pair of numbers, A and B, and it works like that. So this thing is called a point, or you can call it a vector. Now this is mathematics 101, basic mathematics, pre-calculus. Okay, and when you are learning vectors, then it becomes linear algebra. Then it becomes fantastic, phantasmagorical. So how are you guys? We have 3 people watching, and nobody is here yet. And you guys, what is this? Okay, so you guys join my Discord channel. Okay, make it popular. Okay, so let's. So what are we going to do? So we are going to. Well, I was planning to talk about JavaScript. Okay, I mean not JavaScript. We are going to code JavaScript. So let's. Okay, so let me show you. I gotta show you everything. So you can see here is my system. Okay, here's my hand. I'm drawing here. This is the device. Okay, underneath it, you see I can. Okay, so I hold my camera. So I want to drag this so it becomes elongated strip. And in this window, what you see is all my Emacs commands. Okay, so for example, I click here, you can see over there mouse movement. Okay, and I can select. So all my Emacs command shows on this window, and so I'm using the pen. So this I'm showing you because so that you can go by it right here. Okay, you go to Xali keyboard blog, then you can find this page. Then oops, then you buy this one. Okay, this thing is cheap, $40 only. Good morning, Bart Bartholomew J.S. J Simpson. How are you doing, Bart? So, Bart, you're gonna buy this one. Well, but you are in Germany. So, and of course, I have my Kinesis keyboard and I have this fantastic spin wheel. Okay, I'm gonna show you the power of the spin wheel. Okay, hold on a second. And we're gonna keep going. We're gonna do the mathematics. So, Bart, where is the girl? Where is the Zitron crazy? Your partner? She hasn't been to the show for a while. So you see, so this is my keyboard blog, and you go over to my where is it? My mouse section. Okay, you go over to my mouse section. You can see the demonstration of the spin. You fantastic, fantastic, and this is the mouse. Okay, this one you go buy it cheap. Okay, so that's about that. Where is bamboo? Well, I don't have the bamboo version. I have the version I have is the one I have is cheap Chinese made version. Okay, and so I'm gonna show you stuff. And first of all, so let's copy this page and I paste it. Okay, so some of you guys can go buy it. That's how I make my bread. Okay, so let's go back. Drawing tablet. Okay, so I'm gonna paste it here. Drawing tablet and Logitech pen. Go back here. And good morning, Ztron Crazy. Say something, Ztron. So Logitech. So we actually, I'm thinking, we are going to do the mathematics, vector. So let's not. So let's learn something, But you should learn it. You you watch every of my video, but you have to learn something. I mean, not aside from watching it for entertainment purposes. You could also follow through, and if you do that, you don't need to go to universities anymore because you are learning lots of stuff here. You have to do homework. Like every hour of video, there's 1 hour of homework. Okay, so that's about my tablet. But before I show you something, let me demonstrate Chinese writing. Okay, actually, Chinese, the most complicated writing system. Actually, Japanese is actually more complicated because Japanese. Where is my camera pointing at? Okay, hold on a second. So, because actually Japanese. So here you can see I write. Okay, so I guess should I enlarge it? No, I guess. So Japanese, it turns out. Where do I want to go? Japanese turns out the Japanese writing system is more complex than Chinese because it actually uses all the Chinese characters, not all, but 3,000 of it. So, and plus they have the Japanese phonetic symbols. But anyway, I'm going to show you. I'm going to show you Chinese writing system today. Okay, so I mean I'm going to demonstrate that, but mostly I'm going to show you about the vectors math. I think we're gonna do that. So wait, how long have I been talking? Let's stop this. Yeah, let's stop that. And let's go back to where? To here. So you guys can see it, right? Yeah, so the demonstration. So let's write some Chinese. Oh yeah, so to write some Chinese, let's go to GIMP. Okay, there is slight lag. 有一点uh, lag. How do you say lag in Chinese? I don't speak Chinese at home, so I rarely speak Chinese, and I haven't written Chinese for 10 years also. Uh, so that's how you write Chinese. Some of the Chinese characters. This is Chinese. Okay, 中文. Okay, middle language. Now, but however, let's go to. So is that fun? Have you ever seen Chinese writing Chinese? Have you ever? But okay, but you are the only one here who is talking, so you are the center of my attention. So let's go to Xali Chinese. Let's go there. And place Chinese chess. Yes, that's good. Chinese input methods. Yes, that's good. We talked about Japanese input methods yesterday, and this drum keyboard is fantastic. It's fun. Book the Chinese typewriter history. Okay, there is a book. Intro to Chinese punctuation. Yes, you guys can read that. And Emacs Chinese input. Of course, you can use Emacs to type Chinese. And yesterday we did a demonstration of typing Japanese in real time. In fact, that's my first time typing Japanese. Okay, so actually, let me go to Chinese over here. So Chinese. Okay, so this is a list of the most frequently used Chinese characters. That's this list. Okay, the most frequently used Chinese characters. So let's go over here. Let's go over here. Let's paste it. Okay, and I'm going to show you how do I write this. Okay, so let's see. So you are seeing that window. Then I need to go to GIMP. Langlois. Good morning, Langlois. So new Langlois always have interesting things to tell us. So new window. Okay, I'm going to write these Chinese characters, my friends. Okay, so actually that I have to write it a little bit slowly because there is lag when I'm doing video. Okay, that uh, I can write faster but if I write faster, there's the lag. So let's write the first column. Column. Okay. Okay, so we are up here, and the 当然, these two words means of course. Now there's some strokes are not showing because I'm writing too fast. So there is some it doesn't. I have to write it slowly because otherwise the stroke doesn't show up. I blame to the computer. I don't have a powerful enough computer. In fact, anyway, that's demonstration of some of the Chinese writings. So Bart says, Daniel Lang, who's been talking about me on Discord? Who else? Me talking about you. So are you on Discord? What is your ID? Discord account ID? Okay, so that's about Chinese. We're gonna close this down. Okay, close this down. Uh, discard changes. Well, should we save it? Save us. Okay. Well, actually, we don't want to save it. We want to export. The GIMP idiotic. They started to have export instead of save. Well, I can understand why because um, so saving documents. Actually, I don't want to save in documents. Stupid. Oh, then it's gonna ask you these things. Close that. Discard changes. So don't you have a Mac, which would mean you have no computer at all? Don't you have a Mac, which would mean you have no computer at all? Not funny, man. Not humorous. That's a failed joke. Your joke failed. So what are we going to do today? So well, the plan is that I'm going to start to code JavaScript. Let's get on with it then. Okay, so let's get on with coding JavaScript. So let's begin that, and let's begin to do that. coding. So stop with these Chinese keyboards. We don't. Okay, close that. Chinese drum keyboard. Guys, look at this phantasmagorical Chinese drum keyboards. That's how you use it. Now, this is actually a April Fool's Day of Google Japan about 10 years ago. And all the nerds posting this every year, the idiotic nerds, because when they see this, they think, oh my God, this is so, they find it, they find it funny. I don't, it's really not funny if you know Chinese, well, because the Americans or European speakers, they are not familiar with these thousands of characters. So when they see this, it's more funny to them. But if you are Chinese or Japanese, you grew up with it. It's not really that funny. Okay, but anyway, this Japanese one, like if you read Chinese, you can tell all these characters. In fact, all these characters on this keyboard, you can tell it's fake. Why? Because these characters, many of them are rarely used. In Chinese characters, literally, you have practically you need to know every let's say high school student knows 3,000 4,000 Chinese characters. If you're in college, if you graduate college, you know maybe 6,000 6,000 Chinese characters. But if you look at in a dictionary, there are like 10,000 20,000 30,000 characters. So if you look at that, vast majority of them are rarely used. Uh, so anyway, so that's Chinese characters, okay. And this, then you have this one. This is mostly Japanese kana, Japanese keyboards, okay. So you got these photos. Okay, so let's close that. Let's get back to vectors then. The mathematics of vectors. Intro to Chinese punctuation. Now, this you guys might find it interesting because I show you how Chinese punctuation are used and how it differs from English ones. But basically, they are the same. Okay. Well, basically, let's say 200 years ago, when you write Chinese, you don't write punctuations in general. You don't have punctuations. You don't use them. You might use space, but you don't really use punctuations 200 years ago. Then you started to have punctuations. But anyway, so that is about that. Copy, close, back to Emacs here, and Chinese drum keyboard, punctuations, drum keyboard, magnify, and delete that and show in browser. So Bar says, don't you have a Mac? So Bar says, okay. Okay, so shall we go to start to talk about vectors? There are 6 people watching. I suppose I should. Okay, let's go to vectors. So vectors, now the serious stuff, mathematics, commence the serious stuff. Let's see. Xar Art blog. So first of all, I need to go to Xar Draw. Wait. Draw. Okay, so I need to find the. So by the way, we were doing this. This doesn't even. We were doing this the other day. That is why we want to write vectors. I mean, that's why we want to write the matrix and the stuff. Okay, so let's see. TypeScript. Okay, so actually, so here are the bunch of vector functions, and today we are going to write write vector function, vector and matrix functions, okay, in JavaScript. Okay, so first of all, begin a JavaScript language. Okay, so move it there. Then we gonna copy some of these here, so we have a easier time. So hold on a second. Let's close it. Let's open a new window. Well, not that. Uh, oh God, I hate this. Uh, let's start Emacs again. Fresh start. Close that window. Close that window. So I got my Emacs. Let's open a new window, move it here, and start command log mod. And create a new window, and let's make this window set background color. Yeah, list color display. Comfy Crash Hacker. Welcome aboard. Crash Hacker is a hacker of high order. Crash Hacker is a artificial intelligence on visual image recognition. Good morning, Crash Hacker. Good morning. Good night to Japan. So what are we doing? I got confused. Okay, we need to get some vectors going. You know, so Crash Hacker, this is probably gonna be boring to you since you are doing artificial intelligence um, image face recognition. Was it face recognition or what? I mean, what exactly? Like, can you tell us? That would be interesting. Yeah, tell us, Crash Hacker. What is your research about? Meanwhile, I do this vector here. I do this vector stuff here. You know, the basics mathematics of writing JavaScript functions to do rotation matrices, linear transformation matrices, and um, there it is. Okay, so that. Okay, so skeletal. What skeletal? Oh, record. Oh, I remember. So you have a human. For example, the camera is pointing at a sports stadium, soccer or football, and people are moving. And so you have a camera pointed at it, and you want to determine. Basically, you want the computer to draw a skeleton, like stick figures, knowing where is the joint, where is the arm, right? So basically, the fundamentals of image recognition, human skeleton from videos. Yes, that's right. I follow your channel. What do you mean you follow my channel? My YouTube channel? Good morning. Too cool for school. So too cool for school. Are you a JavaScript coder? I forgot. And where you from? I forgot all that. So I'm a little bit confused. So let's start coding. Okay. So actually, if we're gonna start coding, I mean, I'm gonna start to explain these things, and we are not going to be chatting anymore because there's a lot to do here. So let's just begin typing. Okay. So actually magnify. We are going to write a bunch of functions that does matrix and vector. Okay, and the multiplication, and these functions will work in any dimensions. For example, like we talked before, when we have a vector, you can see on this page that's a two-dimensional vector represented by 2 points. But in 3 dimension, you have x, y, and you have z axis, going out, and so it's represented by 3 numbers. So each point in space, or you can call it vectors, is represented by 3 numbers. Now in 4th dimension, don't worry about what it is, but mathematically in 4th dimension it's the same thing. It's just a number. It's a point in 4th dimension is a number represented by 4 numbers, and same thing for 5th dimension, 6th dimension. So we are going to write a function that compute vectors in arbitrary dimensions. So let's get back to so let's begin. So first of all, we define some of the conveniences functions. So this range function create a range. This range function, just like Python range, it creates an array and the dot product of 2 functions, 2 vectors. Okay, so let's modify this. I'm gonna show you. Okay, so actually delete all that. So dot product of 2 vectors. What does it mean? It means we want, for example, we have ABC dot ABC dot by XYZ is equals to is A times X, B times Y, C times Z, and you add them together. Okay, so it's like that. PRODUC, this is what dot product means. Okay. Okay, this toolbox annoying. Can we get rid of it over here? So okay. So config skeletal SMH. What does SMH? What does SMH mean? So hello everyone. So cool for school. So Crash Hacker says yeah. So it can be used to pose estimations and generate poses. Oh, okay. I know what you talk about. No, this is completely different, and you are also pretty good at it. Okay, let's continue with the vector stuff. I don't know how we already been talking for 30 minutes. Let's do another 30 minutes. Let's see where we go. So dot product. Okay, so this is what dot product means, and we are just going to write a function for it. And now we already have a function. You can see now this is a TypeScript syntax. Let me remove the TypeScript. Okay, now it's JavaScript. So this function does a dot product of a vector in 2 dimensions. You see, that's not what we want. We want a function that's generalized for any dimension of vectors. We want to when the vector has 3 numbers or 4 numbers, we can add 2 of them together. That's called dot product. Okay, so how do you do that? Okay, so vector dot 2 vectors. Vectors can be of any dimension. Okay, so this is partly JavaScript tutorial. So these vectors it will be vector dot dot dot. Let me show you the advanced use of JavaScript, ECMAScript 2015. So this is actually the way we write it. So let's say vect, not vector. Okay, so vect dot 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 means you have one or more vectors. So this is actually represent one or more vectors, and you want the result to be let me show you here, but I forgot the syntax, so let's look up the syntax. So you go to Xali JavaScript in depth, then you let's see. Okay, so wait, so close that, close that, close that. So Xali JavaScript in depth, then you go to JavaScript in depth. That's correct. You want let constant variable. Okay, so we want destructuring assignment. Actually, we are defining a function. So uh, we want this argument destructure. So this is how you do it. Actually, do I need to explain it? Actually, I should, but I don't know what I'm doing. So actually, argument destructure is not what we want. What we want is the rest param. Okay, you see there it is. So I got it incorrect. So let's go to rest params. Okay. By the way, by the way, you go to my talk show and buy my tutorial. Okay, let's put it here. So JavaScript, uh, my JavaScript in depth. I mentioned this a few times. This is JavaScript in depth. You got the best book in. I claim this is to be the best JavaScript book in English language. Okay, including all printed ones. So if you like it, you might give it a shot. You like it, you buy it. Okay, so that's about that. So let's back to the JavaScript rest parameters. Okay, function rest parameters. So you give it three dots followed by a name. The three dots followed by a name in function body. The name is received as an array. Okay, so that's what it is. So let's go back to the code. Where's our code? There. So here the vector there is a vector of any dimension. So basically it's an array, but what we want to do here? So you see, we want to do this. We want to do that, but we want it to be any dimension. So the addition can be done by a reduce function, okay, later on. But first of all, you are given a bunch of vectors in an array, which is a nested array. So you are given an array. Each element is a vector, and that vector may have four elements. Four numbers, four-dimensional vector. Anyway, so you have an array. Each element is a vector. Now, what you want to do is you want to add the corresponding components of a vector into together. I mean, you want to multiply like this. Okay, like this example here: a times x, b times y, c times z, or like this. So how we do it? Uh, so you see this how do you do it? I have to think actually. The easiest way is to write a for loop, but I don't want to use for loop. We want to use functional programming. So anyway, let me think for a minute. Okay, so you got a bunch of vectors, and the result will be one single vector, right? The result will be one single vector. Actually, yeah, that's it. I got it. So vector dot reduce it, motherfucker. So you see what does why reduce? Because the input is a bunch of vectors, bunch of elements. It's an array, and the result will be just one thing. So basically, reduce collapse the array. So the reduce now in reduce, first of all, we need to give a function. So arrow function. So we give it a arrow function, and the arrow function will be a vector. Okay. So this should be vectors because there are many of them. Okay, and here we say vect. Okay, this is represent one single vector, and one single vector will return so your function. So this function, this arrow function, will be applied to two vectors. Do I make sense? Like, do I make sense, or am I just talking to myself? Okay. Um, you see this function here. Okay, this is getting a bit complicated. So initial value, I don't think we need it. So let's make it clear here. Okay, so here you have a function. The input is the input vector 1 and vector 1 and vector 2. Okay, so that's the input because we are calling reduce. So it takes two vectors, then the result will be like that. Okay, so basically like that. How do you how do you express this? So let me just type it out. So this would be like this. Okay, so this would be A1, A2, A3, A4. Let's say four vector. I mean, four-dimensional vector, and over here it will be B1, B2, B3, B4. Okay, and the result should be the component of that added by the component of that. So it will be something like this. Okay, so let me write it. Not add, but multiply. Okay, so we there it is. So A2 times B2, A3 times B3, A4 times B4. Okay, so actually this is the result we want. Okay, so actually like that. If the input are two four-dimensional vectors like that, then our reduced function should return this. So A1 B1, A2 B2, A3 B3, A4 B4. It returns one single vector of that dimension. Right. That's our first reduce needs to do. But the problem is, you see, we need to express, you see, in this formula, we have the explicit components. We are using the explicit components. But over here, the V1, V2, we do not know how many dimensions it is. So how do you do this? I have to think, actually. I have to think about this. So, okay, so this is getting oh, 3 person. Everyone is gun home. Uh, okay, I'm just gonna work out myself then. Okay, so So we need to, so this reduce, so we need to write a function a1 a2 vectors. Okay, so we don't know the dimension. It returns a vector. Okay, so it returns a vector. We don't know the length. Map. So can we use map? No. Uh, well, how do you do this? First of all, is the reduce correct? Yes, it's correct. The problem is to turn this into this line, but without using the components. So two vectors becomes one vector. So two vectors becomes one vector. Yeah, actually, I don't know how to do that unless you use loop, for loop. But we don't want to use for loop. That's the thing. So if JavaScript has parallel map, in Mathematica it's called map thread, or in common Lisp, in Lisp you have a map function that takes a second argument. Basically, the argument can be arbitrary number of lists. Then it will map parallel. That's what we need. But JavaScript do not have that. Let's go look at JavaScript array functions. So array, let's look at array parents and so on, and array prototype. Okay. Let's see, array from, array to. No, let's look at array prototype. Okay, so array prototype, you got bunch of functions. So length constructor, pop, push, shift, unshift, splice, fill, copy with no, entries, keys, values, map for each. Okay, yeah, for each, right. For each, that's what we need to do. Stupid JavaScript. Okay, for each element in array, you give it a arrow function. Okay, so arrow function I. So let's look at for each. You need also the index. And the function is passed 3 arguments. Okay, so the function is passed 3 arguments. Current element, that's x. Then the current index, that's I. Okay, that's what we need. So this function, current element, current index. Okay, so it returns. Oh, not for each. Actually, we need the map. There it is. X times, so that is that. Okay. And in fact, We got that. So that's how you express it. V1 map, then the element of V1 and the index, so element of V1 times the corresponding element in V2. That's how you do it. So that, are you programmed with C++? No, I'm doing JavaScript. So once we have that, you see, once we do this, the result is one vector of nth dimension. Then we just do another reduce. Okay, we just do dot reduce again, functional programming. Now this time it's easy. All we have to do is just add them all together. So AB, no, the add the vectors elements together. So so AB, you just say A plus B. Yeah, actually that's it. Okay, so actually this is our function. This is actually done, although it's hard to read. Let me clean it. So this is the function, dot product of two vectors. Vectors can be of any dimension. And the first one is dot product of two vectors. Vector must be 2D. Okay. So actually, let's make it simpler. Okay. I mean, let's make it easier to see what we are doing. So for example, vector dot, this one will be called vector dot 2D. Okay. And this one will be vector dot 3D. So this will be A2, A3, B3, then plus A3 times B3. Can you see that? Yeah. So now, what about 4D and 5D and 6D and so on? So we are creating this new function that does everything in one shot, one fucking shot. Okay, so this is our fantastic function. So let me clear the code a little bit so it's easier to see. So it becomes vector reduce. Okay, actually this let's clear the code. Okay, vector reduce map, and yeah, that's the code. But I don't know if you can read it. It's kind of functional programming in JavaScript. The JavaScript syntax is very bad, so that's why it's hard to format them so it's readable. But anyway, so I think this is how it works. Okay, actually, so vector, actually the dot 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 should be before, not after. Okay, wait, is it before or after? So let's go back to JavaScript in depth, and let's go look at the rest parameters. So it should be in before. Okay, so this is a generalized version. Let's test. Okay, let's just test, see if it works. So first of all, f range, let's say 5. Okay, and constant arrow function. So constant, constant. So let's say my array, my vec. Okay, vec a. That doesn't make sense at all. What are we doing? Vect a is equals to 1, 2, 3. Okay, let's just say 1, 2. Vector b 3, 4. Now we gonna call okay, so let's run this. let's see. Okay, so I got some error here, and oh yeah, we don't need this range. Remove that. Okay, let's do it again. So the result is 11. So that means 1 plus 3 is 4. 2 plus 4 is 6. 1 plus 3 is 4. 2 plus 4 is 6. 4 times 4. What? Wait, 1 times 3 is 3. 2 times 4 is 8. 8 plus 3 is 11. So that is why the result is 11. Correct. So this is correct. Now let's use our fancy version. Okay, let's see if it works. Our fancy generalized version. Let's run it. 11. Ooh, success. Success. Okay, so actually, now let's do this again. Okay, so actually, so yeah. So let's, instead of constant, let's say let. Okay. So this time we're gonna have 3 numbers. Let's say with random number. Okay, and this gonna be 3D. Okay, and VA V2. Oh, actually, dot product. Yeah. So, oh, actually, our code is actually far more generalized than we need, because the argument to our code at most is just 2 vectors. But here we have actually we made it so that it allows any arbitrary of vectors. Yeah, but dot product is only defined for 2 vectors. So anyway, so our code turns out to be more generalized. So anyway, let's run this to see if it works. Run it. Okay, let VA. So what is the problem? Identifier VA has already been declared. Yeah, shut up. So okay, so okay, so let's change them back to constant. Okay, so now VC VD. Okay, run it. Okay, so I need to change here too. VC VD. Run it. Fantastic. They agree. You can see the result. They agree. Actually, so we are done with this generalized dot function. Dot product of 2 vectors. Vectors can be of any dimension. Okay, so what are we gonna do now? So it's kind of is it boring? It's already 50 minutes. Is it boring? Actually, we have, originally I have a lot to do, but actually explaining it takes a lot of time. So here's the other code. So basically on the left window you can see all this code, but these code are designed for 2-dimensional vectors only. So actually, so let me show you. So you can see you have the dot product of 2 vectors, but that's only for 2-dimensional vectors. Hey, good morning, George. And then we have angle between 2 vectors. Yeah, so this code also need to be generalized for 3 dimension. And you have, okay, so you have vector length. This also needs to be generalized for higher dimension. Actually, that works. So let's write it, okay? Returns the length of the vector. Now the length here means the geometry of length, not number of elements. The geometry of length, which means you see it means here to here. Can we do it? Oh yeah, because I have auto click on. So that's the L length, and that is our code do here. So that's this code. That's this code. Actually, we don't need the number here. So v is a vector, and the math hypo t is a function from JavaScript 2015. So this is a powerful code. It just returns the length of the vector. Doesn't matter how many dimension it is. You know what it you know what do you know the math function of it? So what not so what so what are we gonna do? Should we continue with this or talk random? Because we already screwed up, I think. Let's see. Should we continue about vectors, or should we go somewhere else? And maybe that's it for today, because already. Let's see what are people saying here. Ooh, King Kareem, William Marcel, Radiohead. What is this? Oh God, King Herring. Uh, okay, here's what we're gonna do. Write. We're gonna continue for a bit. Let's continue this. So this hypotenuse, you know what it means? Let me show you what it means. So let me show you. Okay, so return the length of vector of 2D vector of a 2D vector. Okay, so vlen 2D. Okay, share research on Conlan. Oh, that's a great suggestion. Screw the mathematics, because it's kind of boring, and I'm not, really doing it in a concentrated way. In fact, we did 2 videos on these math vectors, but every time it takes a long time. It's like, I suppose that's not well, partly because I'm doing video. Well, what I'm saying is that if you look at the professors, they teach these things. It does take a long time. You have to explain all the things. So Conlan, what about share research on Conlan? Oh, what I don't have any. So what is am I gonna talk about that? So I was reading. Okay, so I was reading Volapük. Okay, Volapük. This is a constructed language. Um, I had an interest. I had an interest about constructed languages in since 1990s. So back then you don't have internet, so I went to the library. I read quite a few books about them. There's Esperanto. At the time, Esperanto is the most popular one, still is today. So you have Esperanto and constructed languages. So let me give you guys a short account of what these constructed languages are about. So constructed languages, they are it used to be, we call it artificial languages, but I think since 2010 or something, people started to say constructed languages more popular for reasons I don't know why. I suppose the phrase constructed languages is more suitable because they are constructed. So why do people, it's just these are languages intended for human communication. These languages are created out of the blue, unlike natural languages such as English, French, Chinese, Japanese, Korean. These Spanish. These are naturally developed languages, but since modern days, we started to know that, why don't we create a language out of the blue? Why do people want to do that? For a few reasons. One reason is that natural languages is very complex. Okay, for example, in English, you have a whole bunch of uh, complex grammars and exceptions in spelling, exceptions in pronunciation, and the roots, the words roots doesn't make sense. For example, let's see what the example. As let's see. Okay, let's go to wordy English, my wordy English blog. Okay, so I have some example here. I remember there's lots of examples. For example, there it is: sleep, asleep, sexual, and asexual. You see that there? You see, when you say sexual and asexual, the you add the prefix there, a, to mean almost like none of it. So sexual is like something, some animal is sexual, but if you say asexual, that means you don't have sex, you are not interested in sex, or you don't, no sex. So the prefix a is kind of means none, or so. But however, you have sleep and asleep, but the word asleep does not mean no sleep. It means you are sleeping. So there is a kind of a inconsistency, you see. And also, since you have a, if you add a in front of a word to mean none of it, then does that mean every word that start with a also means none of it, none of the it of the following word? No, it doesn't mean that, because English is not, such a consistent, regular language. And we have lots of these kind of examples. So sexual, asexual, sleep, asleeps, linguistical conflict, that is English. Then you have an, in. Okay, so for example, let me show you this: a versus un versus in. For example, flammable, inflammable. That's a popular example. Okay, flammable, fire. Then you have inflammable. They mean same thing. But however, the problem is that when you add the prefix in, usually it means it doesn't. It's like inactive. For example, active, inactive. They are opposite words. But however, the flammable and inflammable, they are not opposite. They mean the same thing. So you have this problem, the inconsistency problem of English. And this doesn't just happen in English. So you see, flammable, inflammable here it means capable of being set on fire. Flammable, it means the same thing as flammable. But however, then active, inactive, they are opposite. Then you also have undo. For example, undo, do and undo. Then you have understand. Understand. So, but it doesn't mean understand. It doesn't mean understand. Not like not understand. I'm not sure what is the etymology of understand. So you have these kind of funny, these situations, and these are not surprising at all, because almost every language this happens. For example, you have also in English, you have quasi, pseudo, and semi. Okay, that's very interesting prefixes. Quasi, pseudo, semi. They have slightly different meanings. So, and this happens in French, in Chinese, almost every language, in Spanish, almost everywhere. Inconsistent, because they are not regular. These are natural languages. So therefore, people want to have a people started to have the idea that why don't we just create a language by design? So there is no such problem such as this. And there's no irregularity in spelling, no irregularity in grammar, no irregularity in pronunciation. So it should be things should be extremely simple. So people, children, for example, can easily learn the language. Okay, so that is, because education is a big thing. In every country you worry about education because education is quite important. You worry about it. You try to reform spelling, or you try to have spelling bees to encourage people to understand how things are spelled. Why is it so difficult? Because it's quite fucked up. That's natural language, very complex. So each government in each country, they spend, you have committees, educational committees, you have language awareness, things like that. You want people to be educated, at least in writing, and increase literacy. You don't want people to be illiterate. When you look at world statistics, literacy is almost the most important, one of the most important uh, uh, quantity, how to see how advanced is a country, because so reading is important. So that's why, because this education, because so people want to started to think they can create a language. Then if we all just adopt this language, then all this problem will be solved. You will solve billions of dollars, things like that. So that's kind of the origin of constructed languages. One of the reason. Okay, that's one of the reason. There are other reasons. Now the other reason is that, for example, when you have uh, UN, the UN, the United Nations, things like that. Every country go there and talk, about important things. But the language is a barrier. English, French, Spanish, Chinese, Japanese. You can understand each other. So the idea is that if you have a constructed language, each person can speak this language, and we can all communicate. So that's the other significant reason, the goal of constructed language. So everyone can, you no longer have the language barrier problem, and it's easy to learn. So you solve a lot of problems. So that's two issues. Okay, there are also other issues such as cultural issues, culture issues, because language is kind of intimately, it's kind of tied to the culture. For example, you have American culture, United Kingdom culture, you speak English. And because language is developed by people out of a region, over the past thousands of years, so the language, the words in the language, what they mean tends to be associated with this particular culture. English, United Kingdom and America. On the other hand, Chinese, for example, Chinese language, they developed in Asia. They have their, you have many words and concepts, and you don't have in English. So when two countries or multiple countries get together, when you want to speak one language, there is the problem of, like language is a very much a political issue. For example, in Canada, their official language is Quebec, Quebecois, the French Canadian French language, but also English. You might think, oh, why two? Let's just change it all just to English. but that's a problem, because those people who speak Quebecois on the eastern side of the Canada, that means they have to their children have to learn a new language. It also means they are learning a language that doesn't reflect their culture. So it's a problem. You don't, they wouldn't want to just let's switch to English. Meanwhile, in the same way, if you switch to French, then the English speakers, it's a problem. In the same way, you don't want, for example, you don't want Chinese to tell you let's let the world language be Chinese. And in the same way, English too actually, and also when a country invade another country, for example, Japan invades, China, in World War II. Once they invade the country, they typically, often, okay, they force the people to speak their language. Why? Well, because language is very much associated with culture. You want to spread your language, and English too. English, in history, English spread to, are forced upon other people, to speak English. India, for example, and then German, for example, Germany. I think that also happened. Anyway, so my point here is that language is very tightly associated with a culture or a race or a country. And if you are thinking about international language, you have a problem of choosing one language to be the international language, because all the others don't want just to adopt your language to be to be the international one. So that's another reason for the rise of the for the purpose of constructed language. That's these nerds are thinking. I mean, that's ideal. That's an ideal situation. Let's create a language that is, let's sit together, design a language that is easy to learn, that doesn't have cultural bias. It's not English, it's not German, it's not French. It's like neutral, new language, and everyone can learn it and use it for international communication. So that's the three primary reason for the rise of constructed languages. Extremely easy to learn, neutral, no cultural bias, neutral, and to be used as a lingua franca, the international language. Yeah, so that's essentially that's the the force behind the reasons for constructed language. So I was, so in 1990s I was interested in them. So I read a bunch of books. I read at least the first chapters, and the discussion about constructed languages. So you have, so the first one of these is this one, the Volapük. Okay, this one is created in 1880s. Okay, 1880. And it kind of died because there is struggle. There is, I mean, this. So, for example, it's interesting. I read today. So this guy, Johann Martin Schreiler, a German people. Okay, a German person. He, okay, hold on a second. He So he created it. He is a Roman Catholic priest, and he says he felt that God has told him in a dream to create an international language. That's kind of silly. Now remember, this is 1880s. Today, with the anti-God movement, the atheist movement going strong, the you know the the Catholic or religious religion has kind of waned much. So today's society is, pretty much profane. Not like before, because before in 1880s, like everyone has to go to churches and do lots of other things. So anyway, so he created. So I mean, if you look back at the origin, you find it kind of funny. So you have this priest Roman Catholic priest, he felt that God told him to do it, so he created it. Okay, but then you see they have conferences, then they have arguments because the followers who speak this language, who learn this language, they have conventions, these 1880s. They have conventions and they think, there needs to be some change or improvements to the language. But however, this guy refused. He doesn't want any change. He think my design is the best. I don't want any change. So people started to have arguments. Then a bunch, like serious arguments, like they fighting for power. The institute of this, the so he was president and he doesn't, one day he don't want to have anything to do with the organization anymore because so he started another, this academy, academy of Volapük. So there's serious arguments, and eventually, and other people, because he doesn't want to change, so other people created new constructed languages. For example, this one, now Bino. This is one of them, and quite a few, according to Wikipedia. So basically, in the end, this just the death of Volapük, because people don't agree. They want to struggle. The ideal. When this happens, when this Volapük is created, everyone is like, oh, this should be the international language. It'll solve a lot of problems. Peace on earth, like that. But yeah, actually, it's not peace on earth when you want some change. I don't agree. I want my way to be the way. Like Free Software Foundation and open source and the Linux distros. And it's funny, there's a limerick, okay? There's a limerick. A charming young student of Gluck once tried to acquire Volapük, but it sounded so bad that her friends called her mad, and she quit in less than a week. A week is a week, I think. So some observer created this limerick to describe the situation of this Volapük at the time. You see, so Volapük. So anyway, in 1987, 3 years, basically, 7 years, then Esperanto arose. So this guy created Esperanto. So that's another entirely new, different one. So that's about what I don't know about constructed languages. Okay, so that's it. I think. So guys, you still here? So that's it. That's it. I think, George. So George, what do you think? Do you have like opinions? What do you think about constructed languages? Let's see. I'm gonna shut down in a minute or two, I think. Any comments? Any guys? You have 10 people here. So any uh, comments? I'm gonna shut down in a minute. So yeah, so you have Esperanto, then you have quite a few today. You have like 10 or 20 of them. Um, at least, and also some of the. By the way, so I talked about Volapük and Esperanto. These are two primary constructed languages that are designed to be a international language. Okay, but besides this, there are other constructed languages that's designed for other purposes. For example, in the novel Lord of the Rings, and that guy created, a couple of languages. The Elvish language we talked about yesterday or before. in at length. So he created the Elvish language. Why? Because it's a hobby. It's a hobby for him. He's a linguist, so he created the Elvish language for his novel. Partly for his novel Lord of the Rings, but partly also just because it's fun to do for him. So he created this complexity, right? And but there's also Lojban. But anyway, so you have the Elvish language for that's the purpose of that is for entertainment, for hobby, for Lord of the Rings, the novel. But then, for example, in Star Trek, you also have the Klingon language, created out of the science fiction. And what's the purpose? So the Elvish language and Klingon, their purpose is different from the Esperanto and Volapük. So Esperanto, Volapük, they are designed to be international language, but the Elvish language and Klingon, they are kind of just for hobby, for fun, you know, for fun. On the other hand, you have things like Lojban and Loglan. They are created. They are created. The purpose of them is to study the language structure. I mean, Loglan and Lojban, they are created so that they are trying to create a language that is based on logic, the mathematical sense of logic. So they are trying to explore, in other words, to explore what is the most, the logicality of language. Can you do that? Like, so that's the purpose of Lojban. And George says modern Hebrew supposedly is the only successful Conlan. Is that true? Uh, I mean, okay. So I guess, well, I guess I can take what you said for granted. But the problem is, so George says modern Hebrew is the only successful constructed language. You see, the problem is, how do you accept? I mean, how can you call this a constructed language? I think then that's a blurring the line, because uh, that's, I think that's kind of blurring the line. I think, yeah, because okay, so I don't know. I don't know what's the deal, but for me to answer that question, well, I have to answer that because because I have to make a judgment whether that's correct statement. So the statement is modern Hebrew supposedly is the only successful Conlan constructed language. So I have to decide whether modern Hebrew count as a constructed language. Now, in order to decide on that, I need to know to what degree it is constructed. So I think that is a key. So, I'm just talking about my thoughts and sharing my, thought flow about these issues. So, to what degree modern Hebrew is constructed? I don't know. So, I have to read this article. So, I don't know. What are you joking? Are you half joking, George? George probably know a lot about these things. George is very knowledgeable in kind of broadly. Okay, I think that's it for today. So thank you guys for watching. Bye, guys. Oh, so I don't know. Not a joke. That's what people say. Oh, okay. So okay, I gonna check out what's going on there. So, but we might, actually, but so let's do chat. Okay, actually, let's do chat offline. I mean, I can't, I want to do live, but I can't just it would be much better if we can talk like offline. Then 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 we see where to go. We can talk to a lot of people, not just you and me, and also many others. Who watch my video. We and in fact we've done that before. So we are missing you, but so if you join, that would be much fun. I cannot Twitter you. I cannot, master than you. It's no fun. Yeah, and it's not like I have. If you if it's gonna be in email, then it's gonna be, it becomes a work. But this is supposed to be fun. So yeah. So let's talk. Okay. Bye, guys.